zeros, right? If you read the problem, right, they give you a non-zero. A non-zero is basically when you have an imaginary, right? And a real is when the imaginary is not involved, obviously, right? So the question is, which of the following statements must be true regarding the info they gave you, right? And you should have a copy of this. You should be able to read it, right? But the main key point here is that one of the zeros is what? An imaginary. So you have to remember that this imaginary deals with something that we call conjugate theorem. So in simple terms, if you have a positive imaginary, it's always going to come in a pair. So if I have a positive I, I should also have a negative I. So basically that's the whole concept, right? In this case, you have to figure out what's my imaginary. Is it affecting the first number or the second number? And if you notice, I did highlight it in blue, right? So it's the second number. So here we have a negative, so we're missing the positive. So we should also have a zero that involves 0.123 plus 0.987 I. So an imaginary is always going to have two values, one that's positive, one that's negative. Same numbers, different signs, right? So the question is, which of the following statements must be true? Overall, the degree of 5 tells me there's 5 zeros, right? So 2 of them are imaginary, they're non-real, and 3 of them are real. So which of these statements makes the most sense based on the given information? Well, right off the bat, I know conjugate theorem tells me that I should have another imaginary, so I'm assuming it's B, right? 0.123 plus 0.987 I is a zero of M.